This is finding limits when we're going to infinity and how to use these rules about dominant terms. So notice a limit goes to infinity when it's going to say x is going to infinity. So this theorem, when the denominator is bigger, is covered down here. So these are actually very similar to your rational function asymptote rules from our first unit. So that's a good kind of review and consistency. So when you plug in a really big number, if let's see, a is less than b, that means that the denominator wins. So if the denominator is bigger, the limit is equal to 0. We're going to be looking for the highest degree in the numerator and denominator. So for example, if this is x squared and this is just a power of x, the denominator is going to blow up really big. Anything divided by a really big number is 0. What if the powers are equal, like a cubic function divided by a cubic function? So if the powers are equal, you strip the coefficients. So this is like 2x cubed over 3x cubed. The limit is going to be 2/3. And lastly, if the numerator wins, then the limit is either positive or negative infinity, and we have to plug in, I'm going to put that in like quotations, plug in a value for x. The other thing I want to list is kind of the idea of powers. X squared, x cubed, x to the fourth. I think we know how those rank compared to each other, but those are all polynomial functions. So you're also going to see some exponential functions. Exponential functions are even bigger than polynomial functions, so they will always win in a power fight. The ones that will always lose are trig functions like sine of x or cosine of x, because depending on their amplitude, but they usually stay between 1 and -1, 1 and -1. So polynomial functions are going to get bigger and bigger faster than a trig function will. So when you're comparing powers, that's important to keep in mind. So we're going to look at these these 6 problems together and a few other problems on the back page. So example number 1, what power is going to win? It looks like they are equal in powers because they're both linear functions. So if we plug in a really big number for x, we would get like 3 billion divided by 1 billion. This 1,000 or 100 are really insignificant when you're talking billions. So we strip the coefficients and the limit would just approach 3 over 1, which is 3. In example 2, the numerator wins as a power. So what we need to do is plug in a value for x. This is having us plug in a negative value for x. If I plug in a really big negative value, what's going to happen when I square it? It's going to become positive, right? So I just check a negative value in the larger term of the numerator. So I get a positive answer, right? Because a negative number squared is still positive. What if I plug a negative number into the denominator? And I'm just talking about this first term of the denominator. I would get a really big negative number, right? Positive divided by negative. So my answer is negative infinity because a positive divided by a negative is negative. So this time I've got the same function, the numerator wins, but I'm plugging in positive infinity this time. This time I'm going to get a positive divided by a positive, and positive divided by a positive will therefore approach positive infinity. I just want to show you what this looks like on a graph. So if you ever forget the rules, if you can use a calculator, you should be able to figure it out using a graph. So here is this function. We want to see what x is doing towards negative infinity and positive infinity. So I realized I can't see this region of the graph down here, so I'm going to change my window just so you can see down lower on this graph. So see how there's this whole other piece that I couldn't see. I probably zoomed out too far, but you're going to get the idea. As x approaches negative infinity, where's this graph headed? It's headed down. So that's why our answer was negative infinity. As x approaches positive infinity, where's this graph headed? It's headed up towards positive infinity. Example 4 is a little bit different. So example 4 has 3 separate functions. And we didn't learn a lot about properties of logs, but if there's 3 separate functions, you're going to do each part separately and then evaluate it at the end. So the limit of a constant function is always that number because it doesn't matter what I plug in for x, I'm always going to get 7. If I plug in infinity into this fraction, I'm going to get 0, right? Because the denominator gets bigger and bigger and bigger. If I plug a big number into this fraction, the denominator gets bigger and bigger and bigger. So I also get 0. So I just get 7. I would just add together what I got at the end. Let's see, number 5, it looks like the denominator wins with x squared. So the limit is going to approach 0. When I plug in a really big number, this blows up, and something divided by a really big number is 0.00000001. Number 6 has a trig function in it. So remember I said linear functions or polynomials will always beat trig functions. So the denominator wins. So when I plug in a big value, this function will approach 0. So before you attempt this on your own, I think you should try 1, 2, 3, 4, 10, and 12. So pause the video, try those 6 problems, and then come back and make sure you got them correct. And then you are going to complete the rest of that back page as your work for today. So pause the video, and then I'm going to show you the circled answers. And then you're going to go back and finish the rest. Okay, so I'm plugging in a big number. The denominator wins, so the limit will approach 0. It looks like the numerator wins, x cubed. So a negative number would stay negative, and a negative number would become positive. Negative divided by positive is negative infinity. It looks like the powers are equal, so the limit will be 5/4. Looks like the numerator wins. So when I plug in a positive number, positive divided by positive, this will approach positive infinity. Let's see, the powers are equal, so I have to be careful. The coefficients look like -5 and then 3. So it will approach -5/3. Be careful of that negative sign. And number 12, 2 separate functions. You're going to compute each separately. So a constant will always approach the constant. And then this looks like this is 0 because the denominator blows up. So 4. So if you got those 6 correct, then you should be ready to move on to the rest. And ask me if you have any questions.